In this video, we're going to look at some more application problems for right triangle trig, but in this time we're going to look at situations that involve more than one right triangle. So this first example here, we have a firefighter on the ground that sees a fire break through a window. The angle of elevation to the windowsill, so from his eyesight, from the horizontal line up to the windowsill, is 32 degrees. So this windowsill from the angle of elevation from his eyes up to there is 32 degrees. The angle of elevation from what he sees up to the top of the building, so this entire angle, is 40. We know that the firefighter is 72 feet from the building, so that distance is 72 feet. What is the distance? So this is what we're trying to find. What is the distance from the roof to the windowsill? So from the roof to this windowsill point, we want to know what is this distance right here. Now, your first thought might be, okay, use SOHCAHTOA, but the problem is this is not a side of a right triangle. So this segment right here is actually a side of this obtuse triangle. So SOHCAHTOA, if you remember, only works when you have right triangles. But maybe you see in this picture that there are two right triangles. It's just not containing this side. So if you look, you see this right triangle right here. Because remember, this this line right here is horizontal, or this segment is horizontal. This building is always going to be perpendicular, so we know that that's a right triangle. And we also have this larger right triangle. So using highlighters to color code these will be helpful. So we also have this right triangle as well. Again, this angle of elevation is always measured from the horizontal line, and buildings are going to be perpendicular to the ground. So we have these two right triangles, a small one and a large one. So if I could find this entire side right here, let's call that X, and if I could find this smaller side that I don't want, if I call that Y, if I take X and I subtract Y from it, it's going to leave me with exactly what I want. I want this distance right there. So that's how we're going to approach this. We're going to do two right triangle trig problems within the same question, and then we're just going to subtract those values to get what we're looking for, to get that distance that we're looking for. So I'm going to go ahead and write down our acronym to help us remember these trig ratios and to set up our equation. So SOHCAHTOA. So the first thing here is, let's look at the large triangle or the big triangle. Doesn't matter which one you start with. I'm just going to start with the purple triangle. And if I look at the 40 degrees and I go across from that, this is going to be the opposite. This is going to be the adjacent. And we have our hypotenuse. I'm not going to be using the hypotenuse here, so that indicates I'm going to be using tan. So it'll be tan of 40 degrees is equal to the opposite over the adjacent, which is 72. Go ahead and solve this. So we're going to cross multiply. So we have 72 times tan of 40. When I put this in my calculator, remember, I'm making sure I'm in degree mode. I'm making sure that the display is float 12. And then I am not going to be rounding my final answer, or the answer I get, I'm going to be rounding my final answer. So when I'm all done, I'm going to round. So for right now, I'm using this entire value, so I'm going to be writing out the entire decimal that I see. But when I go to actually do the subtraction at the end, I'm going to make sure that I just use the value right from my calculator. I'm not going to try to retype this in. So there's my answer for this distance on the purple triangle, the X value. So now I want to go ahead and focus on the small triangle, or the pink triangle. And now I have my 32. I'm going across from that, so that means side Y is the opposite, the adjacent still the same, the hypotenuse is still the same. So we'll be using tan again, except for it'll be tan of 32 degrees this time, equals the opposite over the adjacent. Put that over 1, cross multiply, so we get Y equals 72 times tan of 32 degrees. Again, typing that into my calculator in degree mode, not going to round my decimal. I'm going to keep everything how it is. So 44.99059333375. And my final distance that I'm looking for is going to be equal to the difference between these. So I'm going to take that 60.415. I'm just going to put dot, dot, dot. So I'm going to take that entire number in my calculator. I'm going to go right up to it. I'm going to arrow up, select it, minus this number here. And again, I'm just putting dot, dot, dot. I'm going to subtract those, and I'm going to round it to the nearest tenth. So I'm going to actually, let me write the exact value first, then I'll round. So I have 60 arrowed up to it, that's 60.415, the entire number, minus, arrow up to the 44.9, hit enter, and I end up with 15.4245801073. I'm going to round that to the nearest tenth, so that means one decimal place. That 2 will keep this a 4. So 15.4 feet is the distance. Again, make sure you are using those entire values from the calculator. You're not rounding until the very end. It's so important for this because your final answer can be off just a little bit by rounding too soon. So be very careful. So that's kind of the strategy. So when you're trying to find a segment that's not part of a right triangle, you have to find right triangles that you can find lengths of, so that you can then find the unknown distance that you're looking for. So in the next situation, you see probably 2 right triangles right off the bat, because we have this tree. So we know that we have right angles here if I draw those in. And then you probably see this big triangle. So let's look at what we're actually trying to find. So it says Alex is standing in the hayloft doorway of a barn looking at a nearby tree. The horizontal distance from Alex to the tree, so from Alex to the tree, is 30 feet. The angle of elevation of a bird at the top of the tree is 32 degrees. So the angle of elevation basically to the bird from where he's standing or where he's looking is 32 degrees. The angle of depression to his dog is 40 degrees. What is the height of the tree? So I want to find this entire distance here. Now remember, you can't do right triangle trig on a triangle that's not a right triangle. So I can't use SOHCAHTOA, combine these, and try to use SOHCAHTOA to find this entire height using this big triangle. Instead, we have to look at this as we have 2 separate right triangles. So if I use this right triangle here, and then I use this triangle right here, and let's say I find X, which is the side of the purple triangle, and Y, which is the side of the pink triangle, add those together, that's going to give me that entire distance that I'm looking for. So again, looking for the right triangles that will allow you to find the unknown segment that you're looking for. So same idea. Start with whatever triangle you want. So let's say start with the purple triangle. And again, we're using SOHCAHTOA, so let's write that out so we have it. If I'm starting with the purple, 40 degrees, I'm going across from it. That's the opposite. This is the adjacent. Not going to be using the hypotenuse. So I'm not going to be using anything with an H, so I'm going to be using tan. So it's tan of 40 degrees is equal to the opposite over the adjacent. Put that over 1, cross multiply. So you get 30 times tan of 40 degrees. So get that entire value in your calculator. So 30 times tan of 40. So 25.17298893353. Again, not rounding till the very end. We're going to do the same thing for the pink triangle. So we have our 32. This is going to be my opposite. I already have my adjacent labeled, not using the hypotenuse again. So it'll be tan. So tan of 32 degrees is equal to the opposite over the adjacent. So very similar setup. So we have 30 times tan of 32. Getting that entire value from the calculator, we get 18.7460805573. And this time, if I want to know the height of the tree, I have to take these and I'm going to be adding them together because I want the total of those two parts. So height of the tree is going to be equal to 25.172. Again, I'm just going to put dot, dot, dot. I'm going to be using these entire values in my calculator. So I'm scrolling up to the 25 plus, scrolling up to the 18, using the entire values. I'm getting 43.9190694.926. And look at the rounding directions, nearest tenth. So that means that the height will be approximately, so look at the nearest tenth, 43 point, that'll just stay a 9. And we're dealing with feet, so 43.9 feet. And that is your height of the tree for this situation. So remember, key ideas here is the fact that you need to look for multiple right triangles so that you can find the unknown segment. So use highlighters to really highlight your two triangles. Anytime that you have an angle and a side involved, that means you're going to be looking to use right triangle trig or SOHCAHTOA. If for some reason this was a situation and there wasn't an angle involved, but you knew two sides, you're trying to find a third, you could use Pythagorean theorem. This method could still apply there. So just keep an eye out for right triangles that you could use SOHCAHTOA or Pythagorean theorem on to be able to find some more complex lengths or distances of unknown objects. So get your key ideas down, try the practice problems, and we will talk about those in class tomorrow.